Alright, so here we're going to talk about writing out Lewis dot structures for ionic bonds or ionic compounds. Okay, so now if you remember, ionic compounds, ionic bonds are typically metals and nonmetals. So what you have here is, start with sodium. Alright, sodium, if you look on the periodic table, has one valence electron. Just put the one dot there. And if you look at chlorine, halogen, has 7 valence electrons. Okay. Now remember, when ionic bonds are formed, it's when the sodium gives up its electron, becomes a cation, and chlorine will pick up that electron, become an anion. So what happens here is that one electron will just come off of sodium and attach to chlorine. And the way we write the final answer, we write it as sodium, and we write it without the electron because obviously it's not there anymore. And we put the sodium symbol in brackets, put a plus sign on the outside, so it represents that it's a sodium ion. And for chlorine, we'll write out the symbol for chlorine, and we'll write out 8 electrons, representing the 7 that it initially had, plus the 1 it took from sodium, and a negative there. And that's how you write sodium chloride, the Lewis dot structure for this ionic compound. Pretty simple. So now, suppose if you have elements or ions with different charges. And so let's look at magnesium and chlorine. All right, as you know, magnesium has 2 valence electrons, and chlorine again has 7. All right, well, magnesium will give up one of its electrons to chlorine, but it still has one more left. Magnesium wants to get rid of both electrons, not just one. So that's where other chlorine comes in. And with its 7 valence electrons, so that other electron will pop off magnesium and go right there, fit right in there perfectly with the second chlorine. Now, to write that, a couple different ways are acceptable. Okay, so again, we'll write the magnesium in brackets, and since it lost 2 electrons, we have a +2 charge. And since we have 2 chlorines, I'll write this down, and I'll have -1 because you get 2 because it's still -1. But then also write a second one. So that represents, we have the 1 magnesium ion and the 2 chlorine ions. Now, for simplicity's sake, this is also acceptable. Right, or Mg +2 in brackets, and then 2 that show that you have 2 chlorine ions with a -1 charge, and balances out the +2 for magnesium, and the +2 goes on the outside here. I apologize. So there you go. All right, do not do okay, not that. That's bad. That's wrong. Wrong. Don't do that. Not good. All right. So here we'll have you do another example here. All right. So I'll write this out, and you can press pause, give you a couple seconds, and then press play again, and see if your answer matches with mine. So we have aluminum, and we have oxygen. All right. So press pause, and we'll come back on. All right, we're back. Let's see how you did. So remember, aluminum has 3 valence electrons. 1, 2, 3. And oxygen has 6. All right. Well, Oxygen needs 2 electrons to fill its valence shell. Okay, well that's aluminum has, well, 2 there, so we're good there. But it has that extra electron there. Still needs to get rid of that. So we're going to pull in this other oxygen. So it'll give up its 3rd electron there. This poor little oxygen still needs another electron. So I have to add another aluminum. 3 there. And I'll take that electron. Goes there. Alright. Now aluminum still has its 2 electrons, still needs to get rid of. So we got a 3rd oxygen. So I'll put that one there, and that one will go there, and there you go. All the electrons have found a new home in the different oxygens. So to write that, write aluminum in brackets, and it lost 3 electrons, so it's a +3, and you get 2 of them. So we have that there. Remember, don't do Al +6, that's wrong. And then with oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Put that in brackets. And we have 3 oxygens. Each of them have a -2. And that is how you do, excuse me, that is how you do Lewis dot structures for ionic